In lesson 5.1.2, okay, so part 2, we are solving equations now. So those identities, all of that still exist. Okay, those are things that we will refer back to as necessary. But it's all about solving equations now. So remember, when you're solving an equation, your job is to find, I think most of these are x, right? What is x equal? So that is our job today. Now, you will notice that up top it says solve the following trigonometric equations over the interval 0 to 2 pi. So that is just saying, okay, 0 to 2 pi represents what? Once around our unit circle, yes? So that's just saying that we want all answers that solve this equation as we go once around the unit circle. Not infinitely many times, not only quadrant 1 answers. We want once around the circle, okay? Which is why I suggested unit circles, trig reference charts, those type of things, so basically your notes page is going to be helpful today, okay? So, as we look at question 1, there's not really solving to do, it's just really answering the question. Sine x equals 1/2. So as I look at that, sine x equals 1/2, what my brain is saying, at what angle does sine equal 1/2?
And this is in radians.
And, okay, so I agree with both 30 degrees and pi over 6. We are going to express our answers in radians today. So it's not that 30 is wrong. I know it's the easier option. However, notice when they give me an interval that is 0 to 2 pi, that is your hint to give your answers in radian form. Okay? Whether you pay attention to the hint or not, totally different story. But, okay. Now, so I agree that sine equals 1/2 at pi over 6. I also put a comma.
I noticed that.
What am I indicating there? There's another answer.
Ugh. Can we even hint?
I'll give you a moment to think before I give the hint.
I think
Or give a hint. So, our interval is 0 to 2 pi, right?
Would it be the negative?
No.
No, because
I was
it's
thinking that,
opposite
but I just
direction,
didn't say that.
or
So my hint
All students take.
is all students take calculus.
in the second quadrant.
And what did we already have as an answer? Not sure that's accurate size, but you get the idea.
5 pi over 6.
Pi over 6. Now, where in what other quadrant does sine equal positive 1/2?
5 pi over 6.
Okay. Not quadrant 4, not quadrant 3, but quadrant 2. And that's because sine is positive there. Okay.
That's
Okay.
crazy.
And so we need, it's a reference angle, right? Pi over 6 is my reference angle. So pi over 6 up from the x-axis is, as you guys said, 5 pi over 6. And now I will box my answer. Now I will make it official. Okay? Now, okay, so here's the deal. These equations today are going to have multiple answers. It's very rare that you'll have one answer. Not that you couldn't just have one answer, but usually there's more than one answer. Okay? And so what I'm going to say is for that, you want to check your unit circle. So I'm going to write a note here. Check the unit circle for other values. So in other words, once you have the initial value, which came from my reference chart, right? Now you're checking the unit circle for your other values. Okay. I'm ready for 2 when you are. And I will say does everybody have the formula page back from the test? The formula page with your unit circle and,
I couldn't remember where it was because the last time I looked at this was like.
okay. Because yeah, that's what I would suggest you use. You should have it. Where is the other story? But I did return them at one point. Okay. Okay, question 2. Cosine x plus 1 equals 0. Starting thoughts?
Subtract.
Okay, so just like any other equation, your job is to get x by itself, yes? So to get x by itself, I'm going to work to get cosine x by itself, which means I am subtracting 1. So then I have cosine x equals negative 1. So the question I'm asking myself, now that I have my trig function by itself, at what angle does cosine equal negative 1? Or I should say, at what angle or angles does cosine equal negative 1?
Well, it equals 1/2 of pi over 3.
I didn't ask about 1/2 though.
Well, but if you could you go? Could you?
I see what she's trying to say.
Yeah,
Would you
like-
Yeah, no. Just no.
So sorry. Just
Before you go any crazy direction, I'm just going to shoot you down.
I wasn't going crazy.
I need a different plan.
Yes, you were. Thought was there.
The thumb was not
It's
there.
okay.
I didn't see the thumb. It was there. I didn't see the
I don't think you should do it. Sophie, please say what's wrong.
Okay, I'm giving you hints. What are these points on the unit circle?
Oh, negative 1, 0 is 180.
In radians.
Pi.
Okay, so I was giving you hints as in I put all 4 points on the axes for the unit circle. But the one that matters is when does cosine equal negative 1? Well, what's the order in an ordered pair? It's cosine, comma, sine, yes?
See, I was looking at it and I'm like, that just seems way too obvious.
Yeah. So we're looking for when does your x coordinate equal negative 1? And that happens over here at pi.
And 3 pi.
What's my ordered pair at 3 pi over 2?
Oh, 0, negative 1. My bad.
0, negative 1.
My finger slipped.
At 0, it's, whoops, 1, 0. And up here at pi over 2, it is 0, 1. Does cosine ever equal negative 1 otherwise?
No.
No, it's just happening at pi.
So that's like
So-
an example of just one answer.
That is a rare example of just one answer. Well, I wouldn't say rare, because there's several on my notes that have just one answer, but it does happen. Okay? Questions there? Thank you, Mara. Okay. Example 3. Cosine squared x plus cosine x minus 2 equals 0. Thoughts?
Well, first you gotta add 2 to the other side. Do you? Nope. Never mind. Let's just scratch that.
I'm not crazy about the idea of adding 2.
I'm not either.
I'm just gonna keep my mouth shut this
Now, and the difference, okay, last time I did want to move that number, didn't I? The difference is last time it was just a cosine x
Yeah.
that I could get by itself. This time, if I move the 2, I don't have just cosine x, I have cosine squared x plus cosine x.
Boom.
And that's not quite as nice to work with.
Can we break up the 2 and find like a Pythagorean identity? Are you not allowed to do that?
That's going to make things worse, not better. It's not that you can't do that. In other words, you're saying, well, actually, yeah, cosine squared minus 1. I see what you're saying is if you see a cosine squared minus 1, that could be a Pythagorean identity. But actually, it's better here that we have all the same trig function as opposed to mixing up a sine squared with a cosine. It would be better to have cosine squared and cosine.
Then I'm.
Here's what I want you to think.
Rich comes back.
Do we fill out a cosine?
Does everybody have a cosine?
No.
Is there a GCF? If there was a GCF, I'd be all for it. But not everybody has a cosine, or cosine x that is. So here's what I want you to think about this. Cosine squared x plus cosine x minus 2 mimics the equation x squared plus x minus 2 equals 0. It mimics that equation, doesn't it? If every place I see a cosine x, I'm just thinking x, and I probably should have used another variable. How would you solve x squared plus x minus 2 equals 0?
Factor that.
You would factor it. Let's go ahead and factor it here so we have the pieces. X squared breaks into x and x. Multiplying to be 2 is 1 and 2, specifically positive 2 minus 1. Okay, agree?
Yes.
Okay, that's what your brain has to think. Now, the deal is, instead of doing that with just x's, we're doing that with cosine x's. Every place we just wrote x, we're now going to write cosine x. So, in other words, this factors. Cosine squared x is going to break up into cosine x times cosine x. Multiplying to be 2 is still 1 and 2. Adding to be the positive 1 in front of cosine, positive 2 minus 1. So yeah, you have to think basic algebra factoring today. Okay? Now, if this is x minus 1, x plus 2 equals 0, what's your solving step? Set them both equal 0. So guess what I'm going to do with the cosines in there? So we're going to say cosine x minus 1 equals 0 and cosine x plus 2 equals 0. Solve those. Cosine x equals 1 or cosine x equals negative 2. Okay, cosine x equals 1. Can I go back to this, what I drew over here?
Yeah.
When does cosine equal 1? 0 degrees or 0 radians. So x equals 0 is that answer. When does cosine x equal negative 2?
Can you just go?
Going around the circle again doesn't change my values. When I go around the circle again, all the same values are still there. They don't double, triple, they're all the same values.
Negative 2 pi.
No.
It doesn't matter how many times or which way you go around here. Its cosine is always going to be 1 at this point. Whether we call this 0, 2 pi, 4 pi, 6 pi, negative 2 pi, negative 4 pi.
No real answers.
So think about your cosine graph. Well, it's a good place to get it. Okay, what's a cosine graph do?
It's a valley.
It's a valley. Where does that valley start at? If we don't have any shifts, no translations, it starts at a high point of 1. And then what's it do? Goes down to negative 1. And then what's it do? Back up to 1. Then what? Negative 1, 1. Negative 1, 1. Does a regular cosine graph, that's all that says that is cosine. Does a regular cosine graph ever go down to negative 2? No, because it alternates between 1 and negative 1. So guess what? This answer is not possible. Cosine will never equal negative 2. And so your only answer here is 0. Okay, so now, I think Connor threw out, what was it, no real solutions or something? That is valid for this half of the problem. However, is my final answer no real solutions? No, because we did have a valid answer on the other piece. Got it? Okay. Next one, number 4. 2 sine squared x plus sine x minus 1 equals 0. Same thing? Does it look like it's going to probably be a quadratic factoring type thing? Now, we're beginners. So as beginners, I'm going to write it up above again. We're going to think of this instead of 2 sine squared x plus sine x minus 1. Basically, every place you see a sine x, just put a plain old variable in there. So I'm going to think of this as 2x squared plus x minus 1 equals 0.
Do you have to do the thing where you like split it?
Okay, so now here's the deal. Bear with me, we don't need product of AC here. Okay, now I will say, sometime not today because I don't want to do it right now, Mrs. Rogers learned a new method that kind of can replace product of AC, and I showed it to Calc and they kind of liked it. So, but it's not for today because we got too much other stuff going on. But not even product of AC, guys. This is an easy one to guess and check. Because what are my only options in this scenario for breaking up 2x squared? 2x squared is going to break into what? 2x times x, right? Because normally it's x times x. Well, 2 can only go 2 times 1. Look at the end. It's multiplying to be 1. What's the only option for multiplying to be 1? 1 and 1. So what's the only thing that you really truly have to think about here? The signs. So now, my 1's need to multiply to be a negative 1. So we have to make that happen. And then we have to get our outsides and our insides to work out to be positive 1. Which means my outsides are 2x times 1. My insides are 1 times x. So where do I need my plus? Where do I need my minus?
Positive on the 2x, right?
Depends on how you mean that. I need 2x essentially to be positive, yes? Which that is going to be 2x times 1. So
yeah.
I need an x plus 1, 2x minus 1. Double check yourself by foiling it out real quick in your head, right? We can foil that. You guys are pros. That wasn't horrible. We didn't have to have product of AC there. Personal opinion. Okay. Now, what were those x's really supposed to be? Signs. So, replace them. This is going to be, instead of 2x minus 1, 2 sine x minus 1. Instead of x plus 1, sine x plus 1. We, of course, are going to do what next? Set each part equal to 0. 2 sine x minus 1 equals 0. And sine x plus 1 equals 0. Next. Move the 1's over. So we have 2 sine x equals 1. Okay. Thank you much, Nick. Did you turn in your review worksheet?
Yeah,
you gave it to me when you walked in and see my pile. Thank you. 2 sine x equals 1. What's this mean here?
When does sine equal 1/2?
When does sine x equal 1/2? Over here, it's going to be when does sine equal negative 1. Okay. So, here we go. When does sine equal 1/2?
5/6.
So Mario, you're answering the question, when does sine equal negative 1/2?
Yes.
And I already drew it up here once, yes? So now when does sine equal I just said that wrong, didn't I?
Yeah.
When does sine equal -1 is where Mario went to. And that is here at where? 3 pi over 2.
And 5 over 6.
Oh, do we have another answer here?
Yeah.
I mean, I made it obvious. I left a space because I wanted to put them in a certain order. But sine equals 1/2.
We gotta go back to the first one.
We've got to, technically we've already answered this question, but on something like that, when it's an answer within a quadrant, there's probably going to be 2. Because every trig function has 2 positive quadrants and 2 negative quadrants, right? So when else does sine equal +1/2? And that is over there in quadrant 2 at 5 pi over 6. So we get 3 answers here. Questions?
Seems reasonable.
Seems reasonable?
That's
Okay.
where I'm at.
Okay, well, let's move on then. Number 5. Or number non-existent because the 5 is hole punched out, but
I'm saying there's no
it's number 5.
I put a little 5 on mine.
There you go. It's number 5.
That's what we're doing.
Okay. Thoughts on number 5? How's this one different from the last ones?
There's a
There are
tangent
two different-
square
there's
and
two
a
They're both square.
We have a tangent
And they're both.
and we have a secant, as opposed to having all the same. Okay?
Yeah.
Well, here's the deal. This life is going to be a lot better if they are all the same.
So, sines and cosines.
Equals 1.
Ooh, no, I don't want to go sines and cosines.
Wait. Yeah. Equals 1, doesn't it? No, because there's a 3.
Okay. So, but Sophie, what are you trying to use?
Pythagorean.
Okay, she's trying to use the Pythagorean identity. Now,
Oh, yeah.
I do want to use the Pythagorean identity, but not the way you're doing it. Okay, what Sophie's looking at is tangent squared minus secant squared would be equal to -1, actually, wouldn't it?
Yeah.
Okay, but regardless, I don't have a tangent squared minus secant squared. I don't have it. Okay? Because it's 3 tangent squared minus secant squared. But here's the deal. We can use that identity to replace either the tangent squared or the secant squared with what it's equal to. And then we will have an equation that is either all tangents or all secants. You see what I'm saying? And if not, I'll make you see it. I'll sell it to you. So now, officially, we could go either way with this. I could go all tangents. I could go all secants. I personally am going to choose for us to go all tangents. And the reason I say that is just we work better with sine, cosine, and tangent. Now, am I saying you couldn't go secants? Not at all. Okay? So, right here is secant squared. By Pythagorean identity, what is secant squared?
1 plus 2.
It is 1 plus tangent squared, yes? So, let's rewrite. I'm going to rewrite this. I still have 3 tangent squared x, right? Minus, now since I'm minusing a quantity, I'm going to put in parentheses. We just said that secant squared is equal to 1 plus tangent squared x. And we still have minus 5 equals 0. Are you okay with what I've done? All I did is I took that secant squared and I replaced it with something it's equal to. And by me doing that, the advantage is now I have all one trig function. I'm not mixing and matching. Okay? Can we do a little bit of cleanup? Okay.
Yes.
So first of all, take 1 step, take 2 steps, whatever. I'm going to distribute my negative. So I'm going to say 3 tangent squared x minus 1 minus tangent squared x minus 5 equals 0. That was just me applying the subtraction, yes? I didn't mess up, did I? Okay. Are there some like terms I can put together?
Yeah.
Yeah? What is 3 tangent squared x minus tangent squared x? 2 tangent squared x. What is minus 1 minus 5? Equals 0. So then I have 2 tangent squared x minus 6 equals 0.
Can you not use like the old properties where it was like the number in front equals the exponent and they just like cancel? Like you take the exponent, or is that one like what's it was from a while ago.
I'm not sure what you're talking about. If the number in front, what?
The one where we didn't. It's like exponent.
You're not thinking of logs, are you?
Stop. I know.
Because logs are.
No, remember because you could do like the log base.
Okay, but these aren't logs.
There.
Oh well.
I have no idea.
Okay, that's the only thing I can figure out. Then. Okay, guys, thoughts on what to do?
It made sense.
Move the 6 over because here's the deal. I only have a tangent squared. So it's just like saying I only have an x squared. So I'm going to move the 6 over. Then I have 2 tangent squared x equals 6. Then I'm going to divide by 2,
Okay. It's 3.
right? 6 divided by 2 is 3. Then what? We're going to square root. The square root of tangent squared is tan x. The square root of 3? Plus or minus the square root of 3. So what's your brain really have to think here? My brain is really thinking, when does tangent x equal positive square root of 3? And when does tangent x equal negative square root of 3?
5 or 6. 5 or 3. 5 or 3.
Okay, so start with the chart. That's our starting point. When does tangent equal square root of 3? And that is pi over 3. Now what? Or should we finish the positives?
And 5 or 6.
No.
It's not equal. Oh, that's what it's equal.
Right here, whoops, it was pi over 3, wasn't it? Right here is pi over 3. Where else is tangent going to equal positive square root of 3? Which quadrant? Quadrant 3, tangent is positive. We need an angle that is the same reference angle. So this one was pi over 3 up from the x-axis. What is pi over 3 down from the x-axis? 4 pi over 3. And here's a hint. If you start with the thirds, you're going to continue with the thirds all throughout the problem. Okay? So, right there, to answer the 2 positive questions, it's pi over 3 and 4 pi over 3. What do we also have to do? This is when is tangent positive. We also have to talk about when is tangent negative. When is tangent negative?
2 pi over 3.
2 pi over 3 and 5 pi over 3. How many answers did I just end up with? 4. Now, think about it, guys. It was plus or minus square root of 3. If plus square root of 3 has 2, and minus square root of 3 has 2, you're looking at 1 per quadrant here, aren't you? Because tangent has 2 positive quadrants, 2 negative quadrants. Okay. 6.
Can we change cotangent to sine or cosine or sine?
Yes, at some point we can, and now is fine. I mean, there's 2 steps I see taking at the beginning. And one of them is, yes, we're going to want cotangent to change to cosine over sine. I usually do that as my second step, so that's why I was, but what's the other step I'm going to want to take? How do we feel about fractions?
We don't like.
We normally want to get rid of them, yes? How do we get rid of this fraction?
Multiply by the reciprocal.
Move it over.
Not reciprocal, just multiply by the denominator. If you want to get rid of a fraction, multiply by the denominator. What's my denominator? Sine x. So those are the 2 first steps, and I'm going to multiply by the sine x first. Because multiplying by the sine x, we get to cancel those there. And then we end up with cosine cubed x equals cotangent x times sine x. But what did Sophie already suggest? Changing cotangent to cosine over sine. So now I have cosine cubed x equals cosine x over sine x times sine x. Oh, now what just happened?
But sine x kind of sounds like a complicated.
Okay. Not sinus, sine x. Although I guess they always make play on words with the medicine names, don't they? So, okay.
That must be nice.
So now, what do I have? Cosine cubed x equals cosine x. Yes, let's make our equation equal to 0. So that means I'm going to keep cosine cubed x and subtract the cosine x over.
Do you then factor out cosine?
Now can we talk GCF?
Yes.
You guys wanted to talk GCF earlier, and I said I was all for it. There just wasn't one on that particular problem. Think of this like x cubed minus x. X cubed minus x would have an x in common. Cosine cubed minus cosine x has a cosine x in common. So factor out cosine x, and you're left with cosine squared x minus 1. Okay. And officially, you could keep factoring cosine squared x minus 1. There's 2 different ways. They're both equally correct. You can keep factoring that. It's difference of squares. Or the fact that we have 2 things multiplying equal to 0, you can set each part equal to 0. So cosine x equals 0, or cosine squared x minus 1 equals 0. If you're watching what I wrote, I jumped a step ahead, had to back up. Now, cosine x equals 0, we're just going to have to answer that here in a moment. What about cosine squared x minus 1? Add 1. So cosine squared x equals 1. Square root it. The square root of cosine squared x is cosine x. What's the square root of 1?
Plus or minus. That's right.
Plus or minus 1.
Oh.
Okay, so we are really answering 3 questions here. When does cosine equal 0? When does cosine equal 1? And when does cosine equal negative 1? Now, I think I'm going to come up here.
That's crazy.
Okay. What are you looking at here?
the ones that are on the lines.
Right here?
Yeah.
Okay, so I jumped back here to this page for a moment. When does cosine equal 0?
Pi over 2.
Pi over 2
3 pi
and
over
3 pi over 2.
Pi over 2, 3 pi over 2. When does cosine equal 1?
0 pi.
Cosine equals 1 at
Every single spot.
0. Cosine equals 1 at 0. When does cosine equal negative 1? At pi. So we have our 4 quadrantal angles here. Cosine equals 0 at pi over 2 and 3 pi over 2. Cosine equals, oh, I forgot to write, I guess I'll just make this plus or minus 1 here. At 0 and at pi. Now, slightly different situation we need to worry about here though. In this problem, we started with a fraction. Fractions, when you get rid of them, can produce extraneous solutions. We need to check for extraneous solutions. So, okay, go back to your, what was my original denominator? Sine x. So what you need to consider is that sine x cannot equal 0. At what locations does sine equal to 0? Because those are not possible answers. So going back to the chart, sine equals 0 at 0 and pi. So what am I really saying there? X cannot be 0 or pi. My only two answers actually end up being pi over 2 and 3 pi over 2. Okay? So, that was because there was a denominator. Doing things like denominators, or multiplying a denominator away, that produces extraneous solutions. If you square both sides of an equation, that can produce extraneous solutions. So we have to watch out for those things, okay? It's not that it happens much in homework, but I think it does happen if I recall. Now, that is probably a good stopping point. Now, here's what I'm going to say, guys. 7 and 8 have very minimal impact on your homework, if I recall. So, I'm going to say do the homework for tomorrow. Okay? So, with that in mind, what I will plan for tomorrow is I will go ahead and show 7 and 8. However, I'm double checking right now. I'm pretty sure they have minimal impact on. The only one it even possibly affects is 61. So there's one problem in homework that is affected by these bottom two. They're not a huge influence. So do your homework. Come with it done tomorrow. 61 we'll have to talk about. You won't know how to do that one. The rest, follow the rest of the, notes that we've already done. Am I making sense here?
Yes.
So homework is due tomorrow. Okay, so we'll spend tomorrow finishing those notes, going over questions. And that should put us at no homework for the weekend. Because I won't do anything else until Monday.
And Sergeant